Good morning. My name is Douglas Núñez, and I will tell about your serviceability limit states, deflation, and cracks in reinforced concrete. Serviceability limit state refer to performance of structures under normal service loads and relates to the usage and or occupancy of the structures. The serviceability limit state is measured by considering the magnitude of deflections, cracks, and vibration of the structure, as well as amounts of surface deterioration of the concrete and corrosions of the reinforcements. Uh, it is very important to delimit deflation of the different elements to ensure good behavior of the entire structure as a whole under service load. When a careful study of deflation in reinforced concrete beams a slab is not carried out, problems generally occur with windows, doors, and partition walls. Excessive deflection in floor slabs can lead to cracking problems in partition walls, deformation in doors and the windows, drainage problem in roof, malfunctioning of equipment and machinery sets. Factors on which deflection depends. The final deflection of the reinforced concrete elements depends of many factors, among which the following can be mentioned. Material properties, degree of cracking, cracking distribution, the history of the structure or element under considerations, and super conditions, and moment of inertia of the cross section. The calculation of the deflection. When is easier to compute the deflection occurring immediately under the application of loads. This can be computed by the use of methods and formulas available for elastic deflation, by considering for the stiffness of the element the effect of cracking and steel reinforcement. When values for the stiffness of the element E and I are not available, the ACE code in section provide a procedure of calculation the effective moment of inertia. Allowable deflection magnitude. The designer must select the limit deflection of the applied to his structure. The AC code, if maximum values of allowable deflection is stable, 24.2.2, consider the type of element to be analyzed, and under load, what load this deflection should be calculated. Crash or fissures. In most reinforced concrete elements properly designated, there are cracks that are generally very small and almost invisible to the naked eye. Cracks can appear even when the element is not subject to the load signs. They can be produced the effect of shrinkage during the hardening process of the concrete. Cracks in reinforced concrete do not follow a definite pattern. Variables affecting crack with the distributions. Among the main variables, we have type of steel reinforcements, anchorage of the steel bars, tensions in the steel reinforcements, bar diameter, coating of the steel bar, current on the crooked elements, indicates placement of reinforcements, and finally terminal screen cage. Location and distribution of crack to node actions. Flexural and shear cracking and torsional cracking and tensile cracks and compression cracking. Finally, reason to the control crack weight. Aesthetics, leakage, and corrosions. Aesthetics cracks between 0.25 and 0.30 millimeters cause concern. Leakage, the width of the cracks should be kept to the minimum to prevent loss of the container liquid and corrosions. The pH near 12 degrees in the mixture, so the risk of corrosion increases. Thanks.